So, I have one problem that I was given yesterday by one of my tutees that I would like to go over because we struggle because of a tiny little mistake we made. So, this is a Calc 3, Calc 4 problem, and it's just asking us to find the local max, minimum, or saddle points if they exist on this for this function, this graph. So, essentially, the first thing that I always say we have to do is to find the critical points. We need to find the critical points. So how do we do that? How do we find the critical points? We are given a formula actually. These are my key formula. It's given by the discriminant. So the critical points we're going to find are going to be when first we have f partial derivative of x, so we take the partial derivative twice with respect to x, multiply by the partial derivative of y, and then minus f partial derivative with respect to x first and then with respect to y squared, right? This is what's gonna give me the discriminant, which is gonna help me figure out my critical how to go about solving the problem. But first, I need to find what are my critical points. To find my critical points, I need to do this. I need to take the partial derivative with respect to x. So that will be 2x, I'm just taking the derivative with respect to x, plus y. And I will do the same thing for y. This will give me x plus 2y plus 1. So this is very important. When we take the derivative with respect to y, this y becomes a constant, which is 1, right? With that, remember from Calc 1 that if we take this and we make both equations equal to 0, we're going to end up finding those critical points, those points where the graph is changing. So this is what I'm going to do. I'm going to do 2x plus y is equal to 0. And then x plus 2y plus 1 is equal to 0. Here I can see that from this equation, I can solve for either x or y, but I want to solve for, let's see, which one will be better. I want to solve for y. So I'll do bring this one that side, so I have y is equal to negative 2x. So with this, I know I have y, I have another equation here, so I can make a system of equation whereby I know the value of y and I can put it here. So now I have x minus x plus 2 times negative 2x plus 1 is equal to 0, which gives me x minus 4x plus 1 is equal to 0. And then from that point, x minus 4x give me negative 3x plus 1, which is equal to 0. And then I can solve for x. I know that x is going to be, I can bring this one that side. So I have negative 3x is equal to negative 1. And then from that point, I divide both sides by negative 3. So I end up with x is equal to 1 over 3. Lovely. So now I know my critical point is going to be when x is 1 over 3. And then what is the critical points? What is the y value? I can just plug it in back in here because I know that y is equal to negative 2 x, negative 2x, yeah. So y will be equal to negative 2 times 1 over 3, which gives me the value of y as being negative 2 over 3. So now I know my critical points. I know what points I'm going to be using in my equation. Now, let's go back. Now we need to determine the determinant. This is going to help us figure out if we have a maximum or a minimum. But even after finding the discriminant, we're going to go down here. These are my rules to find if I have a local maximum or local minimum. If the discriminant is greater than 0, that means that if the discriminant is positive, then we can say that we can have to check now for the second derivative, partial derivative with respect to x. So f of x also has to be greater than 0 for us to have a local minimum. And then for the local maximum, the discriminant has to be greater than 0, and then f of x has to be less than 0, which means it has to be a negative number for local maximum. And then for the saddle point, we just look at the discriminant. Is the discriminant a negative number? If the discriminant is a negative number, we just put the saddle points, and we're going to use those points here that we just found, y and x, plug it back into the original equation to give us those exact points, local maximum, local minimum. However, we have another case when the discriminant is actually equal to 0. When that happens, it's kind of hard to define if we have a local maximum or local minimum. So in that case, we're going to do a different type of math to figure this out. But I don't think we're going to find anything like that for this equation, so I'm just going to leave it on the side. But I'll find another exercise where we're going to be using this in the future. Now, step 2, which is find the discriminant. I hope I'm writing it right. Discriminant. If I made a typo, please forgive me. I'm learning. So discriminant, I hope D. So D, we have the formula. It's going to be f of xx multiplied by f of yy minus f of xy, the whole thing here squared. So with that, I'm going to have to find f of xx here using this. So I'm going to copy them down. So I know that f of x is equal to 2x plus y, and then f of y is equal to x plus 2y plus 1, sorry. Now, if I have to take the second partial derivative with respect to x here, so that would be f of x is equal to 2. And then here, f of y, this will become 0. This will become 0. Then we have 2. Oh, lovely, actually. Please, my notations. Yes. And then I'm going to find the third thing, which is f of xy, which is also the same as f of yx. I hope your professors taught you that, but I can make a video explaining that. I'm just going to choose this one. So f of x y, so if I take the derivative with respect to y here, this will become 0. Didn't mean to erase that. This will become a 0, so a constant. And then we have the derivative of respect to y, that will give me 1. And we can even check that here. Similarly, if I was to take was it 1? Yeah, it was 1. If I have to take with respect to x, this will become 0, this will become 0, and this will become 1. So both are the same essentially. So you don't have to panic about the way we write either f of f with respect to xy or f with yx 1 here. So now with this, plug it in back in my discriminant. So I have 2 times 2 minus 1 squared. Okay, so this gives me d is equal to 4 minus 1, which is d is equal to 3. Okay, now we found d, remember, and we have f of xx here down. Now we go back here. We know that d was positive. That means that, d is greater than 0, so that means that d is 3. So we are in this, either this or here. And recall that f of xx that we just found was 2, so that was also positive. So we end up going back up here. So we have a local minimum here, right? So this tells us that we must have a local minimum somewhere there. But how do you find the actual value? So remember our critical points, these guys here? Yeah, we're going to use them. So we're going to use them in our original function. I'm just going to copy paste this one. Copy and then paste it down here. So this is step 3. Evaluate the results. So I'm just gonna put it like that. So local max or min, local max, min, or saddle points using it's very long actually, using critical points. Lovely. Now I remember my x was 1/3, and then my y was negative 2 over 3. And I bring this back here. I might end up using a calculator, but I can simplify it as well. So x squared, so that'll be 1 over 3 squared plus 1 over 3 times negative 2 over 3. I'm literally just putting x and y here, plus y over 3, so y squared, sorry, so negative 2 over 3 squared plus, what is y, negative 2 over 3. That was quite long. Here I can simplify, I can just distribute all the powers and so on, so I end up with 1 over 9 plus, actually minus, because I'm multiplying each other now, so minus 2 over 9 multiplication. Lovely, love the 9 as a denominator. And then here plus negative 2 to the power of 2, that gives me 4 over 9. Oof, I love this, I'm already loving this. And then here minus 2/3. That was a horrible 3. Now I'm gonna do this whole set of 9 before I move with the 1/3 here. I can do 1 over 9 minus 2 over 9, which gives me negative 1 over 9. Okay, negative 1 over 9 plus 4 over 9, sorry. This would give me actually, yeah, let me just write this down completely. This will give me 3 over 9 minus 2 over 3. It's actually amazing because I can simplify this as 1 over 3 minus 2 over minus 2 over what? Oh, minus 2 over 3. Sorry, my brain just froze for a minute. So that will give me negative 1 over 3. And that is the value that I get for my critical points that side. So yeah, that's it. That is everything that we needed to do. We found the critical points. We found the local max, actually the local mean, I would say. So local mean is happening at this point. Points when x is equal to 1 over 3 and then y is equal to negative 3 over 3, and then the value of that function at that point, that would be, as we just found out, that would be negative 1 over 3. Alrighty, I hope this was helpful because we struggled a little bit to figure this out, but you guys got this. I'll see you in the next video. Bye.